Let's look at how permeability is tested in the field, mostly through pumping tests or through infiltration. So let's go through those phenomena. Here is a confined aquifer. The pervious stratum is bounded by an impervious layer at the bottom and another impervious layer at the top. I have a well here through which I keep pumping, and the discharge is constant. Then I keep pumping. At a certain stage, the water level here becomes constant. So using this principle, we call as a steady pumping test. All that we need to measure is what is the water level at any distance h1 at two points, h1 and h2. They are at a distance of from the center r1 and r2. Using a simple hydraulic equation, I can calculate permeability as Q times log to the base 10 R1 by R2 by 2.7 times H1 minus H2. The distance here to this point is R1. The height with respect to the datum here is H1, and with respect to here H2. Instead of putting two pipes, we can go and measure the water level here, which means at a distance RW, this is 0. I measure the water level within the well, and I can use saying that this ratio can be easily found out. R2 can be the radius of the well, H2 will be 0. So any two measures you need in terms of distance and the height of flow or height of water. And again, we are using simple continuity equation. What is the gradient at any point, and then integrate, so you get the coefficient of permeability from the confined aquifer. If we have unconfined aquifer, bottom is impervious, but the top is, the flow is through the whole stratum. But please remember, once we start pumping, the water level comes down from the freestanding water to the level of the well here. The depth of flow decreases. The thickness of the aquifer is H, but the actual flow is less than that. So what we say is that measure the flow only through the depth over which it is taking place, and we integrate the continuity equation to get the coefficient of permeability in this very simple form. Again, 2.3 times discharge. We are pumping, so you know how much the rate of discharge is. Log to the base 10 R1 by R2. R1 is to the point here, R2 is 0.3, divided by pi into H1 square. I have taken the datum here, minus H2 square will give us the coefficient of permeability for an unconfined aquifer. Similar infiltration test we can do. Here is a tube I push in, and I allow water here, and by measuring at falling head test, I can get this. The flow here is always downward. But once I extend the flow below the tube, the flow is taking place, then the flow can be radial. And again, I use the same falling head test. I have the expression here, and the terms are given, taken from the book. A prime and B prime are given as little long expressions. They are functions of this length L, the diameter D, and the height H. So this is another way you can measure the falling head test infiltration too. In the borehole, we can do at different ends. We put in the pipe, but then we put the perforation so that I ensure the flow is only in this region. There is no flow above that because this is a PVC pipe with no holes, whereas these are all perforations. And again, we have some simple expressions to calculate permeability from these infiltration. Okay.